Hi, welcome to this podcast on two's complement for the OCR Computing A-Level F451 unit. So two's complement is another form of binary number representation. As we had before, if you've looked at the sign and magnitude one, this is a way that we can represent negative numbers in binary. However, this time the most significant bit is not just a sign, it is a minus 128 in the case of an 8-bit byte. The most significant bit is a negative number of that value. Okay, and then the rest of the values are all positive. So 64, 32, 16, 8, 4, 2, 1 are all positive values in an 8-bit byte. So for this example here, we've got minus 128 is marked because we've got a 1 there. Then we've got no 64s, no 32s, 116, 08, 04s, 1, 2 and 1, 1. So that means you've got minus 128 plus 16 plus 2 plus 1, which means you've got minus 128 plus 19, which is therefore equal to minus 109. So it's a relatively simple way to represent a number using a minus at the start there with the value of the first most significant bit. However, there's an easier way to do this. There's an algorithm that we can use to do this, and it will allow us to do it quickly without having to think as much. So what we do first of all, if we want to do the same, minus 109, first thing we do is look at what positive 109 is in a two's complement representation. So positive 109, obviously the first bit is minus 128, so it's not going to be that because it's a positive number. Then we have 64 plus 32 plus 8 plus 4 plus 1 will give us the positive number of 109. So what do we do next now we've got that? Well, we change all the zeros to ones and vice versa, so all the ones to zeros. So if we go back to our number on the yellow line there, we've got now the 0 here changes to a 1, 1 goes to a 0, 1 goes to a 0, 0 goes to a 1, 1 goes to a 0, 1 goes to a 0, 0 goes to a 1 and a 1 goes to 0. So now we've got a number here. Now if we look at this though, this doesn't equal our negative number. If we add this up, what we've got is minus 128 plus 16 plus 2, and that will actually equal minus 110. So what we want to do is, for the third bit, add 1, and it works every time. So if we look at this now, we're adding 1 on this line here. So 0 and a 1 from our addition we know equals 1. There's no carries involved, so it's just a case of transferring this number down at the top now, because 1 and 0 is 1, 0, 0, 0, 0, 0, 0, 1 and 0 is 1, 0 and 0 is 0, 0 and 0 again is 0, and 1 and 0 is 1. Now what we have here at the bottom is our number minus 109. 1001 0011. Let's go up to check it. 1001 0011. Okay, so that is a very simple way to calculate a negative number using two's complement. One of your exam questions you might get will involve you adding together two negative numbers. Now be careful when you do this. You need to check what the actual final value is and check what the value should be in binary. What you'll probably notice usually is it's a bit of a trick question, and you'll find that the value that you come out with will not be the correct number if you did the additional subtraction in the denary way as well. So there'll be a video to show you how to do this in the near future, but for the meantime just be careful if you do get an exam question on something like this. Okay, I hope that helped. That's two's complement, and we hope you enjoyed it, and please come back and see more. Thank you.